We're back with another episode of Solidity Fridays. Welcome to Friday's episode. I'm joined with Tam and Ryan, but also special guest Shafu. And yeah, I'll let you guys introduce yourselves. For any newcomers, Tam, you can start.
Hey, I'm Tamara Ringas. I'm a senior Solidity developer at Alchemia. And yeah, I'm a huge fan of our guest today, Shafu OX. He's a developer at DYAD and host of the Bytecode, which is one of my favorite YouTube channels.
Yeah, go for it.
Yeah, hi, I'm Ryan Noble. I'm a full stack engineer at ChainSafe. I've been working in various aspects of the space for a number of years, and yeah, a bit of a Solidity fanatic.
Go for it, Shafu.
Yeah, nice. Hi guys, my name is Shafu. Tamara, thanks for the kind words. Solidity Fridays was actually the inspiration for the bytecode. So a great job there.
That's cool.
Yeah. My background is in machine learning, actually. I did that for a couple of years, and then in 2019, I switched to Web3. And yeah, I've been doing the smart contracts for DYAD over the couple of last months.
Awesome. Yeah, maybe we should introduce DYAD. So it's the first truly capital efficient decentralized stablecoin. And maybe you want to explain what it is and how you can say that. Just explain a bit.
Yeah, sure. If I can start share my screen, Rebecka, do you have to?
Yeah, let me do that.
Okay.
Yeah, here we go.
Yeah, so DYAD is a stable coin, right? It's multi-collateralized. It currently has two collateral types, ETH and Lido staked ETH. And I'm going to show how it works. I'm going to show the contracts. And to give a brief overview, I want to show this diagram. Okay, so these are basically the main building blocks or the main contracts in the DYAD ecosystem right now. And to start things off, I think we can look at DYAD itself. DYAD is 20. It has a mint function and a burn function, but only the vault manager can call the mint and burn. And yeah, not everyone can call mint and burn, only licensed vault managers. Okay, so we have a licensing system. We have one abstract licensing contract, and we have a vault licenser, and we have a vault manager licenser. They have the same methods. You can add and remove an address, and the licenser is basically a mapping between an address and a Boolean, which says, okay, this address is licensed or not, and the address can be any arbitrary contract, which gives us a lot of flexibility and a lot of upgradability if we want to. Currently, the licenser is called by a multisig, but of course, we want to decentralize that. So we're thinking about some clever governance thing that we will introduce in the future. But currently, it's a multisig. Okay, so we have the Vault Manager licenser, which licenses Vault Manager and gives it the ability to mint and burn new DYAD. And we have the Vault licenser, which licenses new vaults. One vault manager can have several vaults, but one vault is always associated with one vault manager. The interesting part in the DYAD ecosystem, I think, is the DNFT system, which we have. The D just stands for DYAD, so it's a DYAD NFT. And you have to hold one of these DNFTs in order to interact with the DYAD ecosystem. Okay, so DYAD is based on on DNFT's IDs, there are no associations with external addresses or EOAs. It all goes through a DNFT. And the DNFT interaction is always through the vault manager, not through the vault, because we have to obviously, for example, if we need the collateralization ratio of one DNFT over the whole ecosystem, we have to aggregate over every vault which this DNFT currently has. Okay, I think this is a good overview. Let's switch over the implementation, I think. I think that's large enough, right? Looks good? I think so.
Yeah.
Yeah, it does,
Awesome.
I think.
Awesome. Okay, so actually I think it would be a good idea to start from top to bottom from the diagram. Let's start with licenser. As I said, it only has one mapping, is licensed or not. It has one add and remove function. It is only called through only owner, which is a multi-sig right now, which we're definitely going to change in the future. And it sets the is licensed mapping. This is the licenser. And obviously, we have some deploy scripts. When we deployed DYAD, we inherited from this licenser and created a vault licenser and a vault manager licenser. Okay, but the implementation is exactly the same. Okay, let's look at the DNFT, which is the core building block in the DYAD ecosystem. The DNFT is a ERC 721. You can mint an NFT and the price increases incrementally. So we have a start price and a price increase. And for every new NFT, the price gets a little bit higher. At the beginning of DYAD, we thought of capping the DNFTs. But the flexibility that gave us wasn't good enough because any number we choose, if we thought about governance, if we think about maybe you have 5,000 DNFTs and then you have a governance system where you need like 50% of votes or something, maybe it's not enough. So we wanted that flexibility there.
Yeah, I think that was a good decision.
Yeah, I think so too. Obviously, maybe the inside or the investor allocation, people weren't that happy because obviously an unlimited amount of DNFTs maybe doesn't make the number go up. But yeah, that we made that decision.
It's better logically, yeah.
Yeah, exactly. Yeah, speaking about angel investors and developers and so on, we have this Mint Insider NFT, which is called through our multisig that can distribute one DNFT to one EUA, but this is limited. Insider mints is capped. It's actually defined here, which is 4,000.
Okay.
Yeah. Then we have a function called drain, which takes all the fees from the contract and sends them back to the multisig or the governance contract in the future. That's the DNFT. We try to keep the DNFT simple. Obviously, this is immutable. There is no upgradability, and there's actually one feature that I really liked. We implemented, but we didn't in the end, which are DNFT permissions. We have to live with that. Maybe you can build something around it, but for now, this is the DNFTs we have.
Okay, cool. So are these transferable or are they non-transferable?
They're definitely transferable.
Okay,
And,
by being ERC 721 enumerable here.
Exactly.
Cool.
And I think that's part of the fun, right? You have like the DNFT and you build up your positions, but the DNFT is tradable. We are also thinking about doing some visualization things, where you have this DNFT card nicely laid out with each of your positions inside vaults and so on. I think
that sounds cool.
That's a nice abstraction. Okay, let's look at DYAD, which is our stablecoin, which is an ERC20. It has a mint function and a burn function, and the permission that you need in order to call this function is you need to be a licensed vault manager. And when you mint and when you burn, we keep track of the minted DYAD per DNFT. So I think this is the first time where we see the mapping between DNFT ID and some arbitrary amount. In another ecosystem, this would be an EWA, right? So we always have this DNFT ID to something else. We also keep track which vault manager this comes from. We have this vault manager system because we could make the vault manager upgradable, but I'm not the biggest fan of upgradable contracts, and maybe this could be something interesting to talk about later. So we decided against that, but we went with the licensing of vault managers. So in essence, you could change the whole DYAD system by deploying a new vault manager, licensing that through the licensor, and every DNFT switches their collateral to the new system if they want to, right? It's totally opt-in. Which I think is, a trade-off. I think in our case, it's a little better than an upgradable contract. But of course, you could have done upgradable contracts through governance as well. Okay. So the next thing we're going to look at is the vault manager, where we aggregate over each vault, and so in the vault manager we have a internal mapping between DNFTs and the vaults that you have. So you as a DNFT holder can build up positions inside the licensed vaults. For this vault manager, it's capped to 5. It's capped obviously because we have a for loop, and for loops and Solidity are, quite awkward. So we have to limit that to some number. In this case, we choose 5. We have a collateralization ratio for the whole system. So we don't have a collateralization ratio limit for each collateral, but for the overall position, which is 150%. And other designs would be that you say, okay, ETH has a collateralization ratio of 150%, and I don't know, staked ETH has a collateralization ratio of 170. This makes the calculation a bit simpler. So we did an overall collateralization limit. Then we have a liquidation reward for the liquidation system that we have that I'm going to show in a bit. All right. Okay. So you as a DNFT holder, this is the first function that you call in order to interact with the DYAD ecosystem after minting a DNFT, which is you add a vault to your position. Okay, pretty simple. You set the ID of your DNFT, the vault that you want to add. We make sure it's you, and then we add that to the vaults array, or it's actually a set, because addresses cannot be repeated. Some conditions that we check. Is this licensed, and we check. We make sure you're not over the 5 vaults limit. Remove is pretty similar, which is it takes an ID and the vault that you want to remove from your vault's position. A pretty nice symmetry here. We actually, in order, this is important for security. We make sure We check first that you don't have any collateral anymore, which is important for the liquidation, because you could do some front-running things. So we have to make sure it's over that, and we remove the vaults from the set. Okay, the deposit function takes in, again, it always interacts with the NFT, so every function that is externally called by a DNFT takes in the NFT ID. Then you have to specify which vault you want to deposit into, and the amount. We check, is it a valid DNFT? Because we don't need the owner. If you want to deposit for someone else, that's fine. It gets the vault and it transfers these assets to the vault and calls the deposit function inside the vault. This is actually one function that could have been called directly and not through the vault manager. I just think this is a better abstraction. So that's the reason. That's the reason why it's here. Costs a bit more of gas. We are an Ethereum mainnet, so every gas counts. But I think in the long run, it's better for security to go through the vault manager. Okay, when you have deposit, of course, you have withdraw, which calls the vault directly, calls the withdraw function. But we make sure you're not under the collateralization ratio limit of 150%. If you're under it, obviously you cannot remove any more collateral. And here we need to check, are you actually the owner? Because every function that decreases your collateralization ratio, we have to check that it's you. If it's a function that increases the collateralization ratio, anyone can call that. Okay. Then, how do we mint new DYAD? We mint new DYAD through the mint DYAD function in the Vault Manager. Again, it takes the NFT ID, it takes in the amount that you want to mint, it takes the to, which is the EUA that you want to transfer the DYAD to, and then we call DYAD.mint, which, as shown before, keeps track of the minted DYAD per DNFT. We need to make sure that the new collateralization ratio is not under the collateralization ratio limit after minting. And yeah, we emit an event. Okay, then you can burn DYAD if you want to through the burn DYAD function. Just calls DYAD.burn. Again, DYAD.burn increases your collateralization ratio. That's why it is a valid DNFT. So if anyone wants to remove DYAD from your position, they are free to do that. Okay, then we have redeem DYAD. Redeem DYAD is for redeeming one DYAD for a collateral or a collateral type. Again, it takes the DNFT ID, it takes the address that you want to go through, so the vault that you want to take the collateral from. We currently do not support a redeem function where you can go through multiple vaults. But I think that would be a nice utility function that we could build on top of that. Currently, you have to decide which collateral you want to go through. Yeah, we get the current Oracle price, the assets decimals, and we calculate how much DYAD, how much assets do you get for the DYAD you want to redeem. Which is done through the withdraw. So then here we call the withdraw function from the vault manager, which calls the withdraw function from the vault. Okay. Then the liquidation. How does the liquidation work? Obviously, you need some reward. And you have to specify which DNFT you want to liquidate and which DNFT gets the reward. So actually, the liquidation game is an internal game between DNFTs. And then, of course, you have to decide which collateral you want to go through. So actually, the liquidation game is an internal game between DNFTs. So actually, the liquidation game is an internal game between DNFTs. So actually, the liquidation game is an internal game between DNFTs. And Of course, we get the collateralization ratio here. We check, is it actually liquidatable or not? You burn the DYAD, the outstanding DYAD that you minted. And then we have some calculations that we do here in order to calculate the reward that you get. I have a simple Excel, Google Sheet spreadsheet to visualize what is happening here. So here on the right side, it's the collateralization ratio, which is in this case 140%, 130%, 120%, and so on. And this is the liquidator reward that you get. So the collateralization ratio decreases, the liquidator reward gets higher in order to incentivize, hey, when the collateralization ratio goes down, the liquidation reward gets higher. And this is the amount that your DNFT or the liquidator DNFT gets, right? Which is controlled by this liquidation reward constant, which we defined here, the 20%. Okay, so this is the calculation here. And then when we have that, so when we determine, for example, you get 77% or whatever the number is of the collateral, we loop over every vault in the DNFT that is being liquidated, and we move over the collateral. So there is no transfer that is happening here. It's actually a move, and how the move is implemented is just this. So we just take it from the DNFT that is being liquidated and move it to the liquidator DNFT.
I see. So just a balance update.
Yes, exactly. So as you can see here, the vault has a specific interface that it needs to implement. So for example, liquidation function needs this move function to exist, and there are other functions that it also needs, which we're going to look at in a bit when we look at the vault. Okay, how is the collateralization ratio calculated? It gets your minted DYAD. If the DYAD is 0, we just return the max UINT that we have. If it's not 0, we divide by the amount of DYAD you have. And we calculate how much your position is worth in USD. So this get total USD value, which is implemented here, loops over every vault in your position, calls the get USD value, which internally calls an oracle, and returns the current USD value of your collateral, and sums that up and returns it. And after that, we just divide that by DYAD, and that gives us the collateralization ratio of your DNFT. So get USD value is another function that has to be implemented in the vault. Okay, so the other functions are just helper functions, because this enumerable set has to be internal. So we have some public functions that expose some things about the set itself. Okay, let's look at the vault. So how we deploy vaults right now is also pretty interesting, I think. So we wanted we wanted a lot of flexibility for the vaults. So actually, you could create a vault and deploy that, and it could be anything. And it would be a valid DYAD vault if it is licensed through the vault licensor. Obviously, it needs to implement some specific functions. Okay, so right now we are the multisig. I make sure that the vault is correct. in the future, governance would need to determine that the vault has the right interface and uses a collateral that people actually want, right? Okay, so let's look at this particular vault. This is the Rept East vault that is currently deployed and currently holds like 95% of the DNFT's assets in the DYAD ecosystem. Okay, so we import some stuff from Soulmate. I'm a big Soulmate fan. We also import something from OpenZeppelin. We have this tail data timeout thing for the Chainlink Oracle. We need to know which vault manager this vault belongs to. We save the asset, and this is the Oracle. In this case, it's the Chainlink Oracle, but another vault could use another Oracle. We have that flexibility here. We have this mapping ID to asset where we save the DNFT ID to the assets that you currently own. And we have this modifier which checks, are you actually a vault manager or not? Okay, so these are all the functions that are called through the vault manager. So the deposit just increases the ID to asset. The withdraw function decreases that, so we always have that symmetry. Checks, is it the vault manager or not? As I've said, it cannot be called through an EOA. Then we have the move function, which is used for the liquidation, which moves amount from one DNFT to the other. Then we have the get USD value, which is used for the collateralization ratio, which calls into the asset price, and the asset price is the Oracle itself, which currently gets the current price. So the only external dependency that we have in the DYAD ecosystem are the oracles. I don't think oracles are perfect. You know, it's also something we can talk about. Yeah, we thought really hard about a DYAD design where we don't need an oracle, where we don't need an external dependency. We actually built that, went through a solo audit, but it was too complex in the end. So we decided against that because unfortunately the current designs without an oracle very quickly devolve into an algorithmic design, right? Which have a lot of downsides, as we know. So we're doing a lot of research in that area. We have that flexibility. We could deploy a new vault manager in the future that doesn't depend on an oracle, but currently it does. Okay, so this is the vault. This is the first vault we deployed. I think 10 days ago, we deployed the Rep Staked East vault, which is, again, very, very similar to the vault. The only thing which is different is we need to calculate some Lido-specific thing in order to get the Staked East price. So the only difference in this vault is this asset price function. Otherwise, it's totally similar. In the future, if we have some ERC20 that behaves a little bit differently than Rept ETH or Staked ETH, we have the flexibility to change everything inside the vault if you want to. So these are the core contracts of the DYAD ecosystem that we have right now. Maybe a bit of history. It's actually DYAD has an interesting history. This is actually the sixth version of DYAD that we wrote. All other versions were a lot more complicated than that, which I wasn't super happy with, because I'm a big believer in keep it simple, especially if you're writing smart contracts. So I'm pretty happy with that design. But as I've said before, the only thing I'm not super happy with is the Oracle. But it is what it is. You know, we're using Chainlink. That's the dependency we currently have. Maybe one last thing about how we do our deployment. This is obviously 100% Foundry project. Super big fan of Foundry. We have these deployment scripts. So how we do this is we have deploy base, and this deploy base takes the address of the owner and the other parameters. We have some fee and we have some fee recipient because we have a fee in the front end. So if you go through the official DYAD front end, if you deposit new collateral, we take a couple of basis points from that. And yeah, it starts a broadcast. It creates the contracts, deploys them, and returns these addresses. But this is only the deploy base. How it actually deployed on the chain is, if we look on the left side to the files that we have deploy Gurley, we have deployed mainnet, which is just a call into deploy base with the correct with the necessary addresses. So this is how our deployment currently works.
That's beautiful.
Thank you. Yeah, I think this is the best way I implemented this. Maybe there's another way. Maybe there could be like an abstraction in Foundry itself, which enables that. But right now, this is how I do it. And then I have a make file, which I always have, so for example, deploy on Gurley, calls this Gurley script, puts in the RPC, and so on and so forth. I actually have that as a Foundry template if someone's interested in that on my GitHub with some helper functions. So for example, I have this very, very simple Python script, for example, that returns all the addresses after you do a deployment in Foundry.
Nice.
Because I couldn't find that in Foundry itself. So
yeah, at my company we do that, but with shell and bash scripts. It would be cool to do it in Foundry.
Okay, yeah, exactly. So I do that manually. Yeah, talking about the payments contract, where we calculate the fee, we have this payment contract, which is, so every deposit goes through that payment contract. We have a couple of basis points, which is stored in the fee, and then when you deposit, you go through that deposit with fee and deposit ETH with fee, because we wrap ETH for you. So when you're on the front end, you deploy ETH directly, we wrap it for you, we take the fee, and then we move it to the Vault Manager. Deposit with fee is for ERC20s, which you deposit directly. Okay, I think that's it contract-wise. Any questions?
So just to say, I do really appreciate the sort of simplicity of the overall design. Like, it does allow for the extended community to actually branch off of it, do a much more novel business logic without running into a conflict, which I imagine is one of the main reasons. Yeah, it's safe, it's lightweight, but like if you have to do something peculiar in a bespoke instance of a vault, for example, you won't run into conflicts with which is why I imagine you moved from having the Oracle-less implementation, because trying to do reverse valuations, I'm assuming you ran into square rooting at some point, and it kind of makes it hard to then adapt that, I would imagine. So I am quite curious of what that proposed idea was for not having the oracles in. But yeah, it's a great architecture.
Well, thank you. I think so. I don't know, like 2 weeks ago, I saw on Twitter someone flexing. They had like 100 contracts and 700K lines of code for this new thing they're deploying, and I definitely think that's the wrong approach, because you have the ability to extend things, right? You can put in more complexity over time. You don't have to write this monolith thing, go through a super expensive audit where you pay 200, 300K or something, and then deploy that and then hope that nothing happens. So for example, in the auditing process, I strongly believe in solo audits. Write something simple. Get someone really good that does a solo audit, doesn't cost a lot of money, and if he finds something that breaks it, okay, move to the next thing. But yeah, sorry, Tamara, I didn't want to. You wanted to say something?
No, I was just saying I really agree with solo auditors lately. I would rather get 2 solo auditors than one big company that costs double and often miss things sometimes because they're just churning over audits.
Yeah, I agree. And I also had this idea recently. Why don't you grow with your TVL, right? Obviously, if you're, I don't know, if you're eigenlayer, that, okay, the next day you have 1 billion in TVL. Obviously, this approach doesn't work. But in our case, we know we'll not have 100 million TVL in 2 days. We can grow with
probably.
TVL. Well, yeah, probably. You never know. It's a non-linear ecosystem that we live in. But probably you don't have that. So you can grow with your community. You can grow in complexity if you want to. But I think we have something solid here. We're thinking about some really interesting things that I'm starting to build, that we're going to deploy soon, hopefully soon TM. But yeah, this is the DYAD base that we're building on, and I think also the DNFT system that we have is quite interesting. So I know other protocols use NFTs in other ways, but actually making your NFT the base building block of the whole ecosystem.
Your access point.
I think is interesting.
I like that a lot. Yeah, that was a really cool implementation.
Thank you.
I have a few questions as well, but we also have one from MyFry in the audience. It says, can you please explain the liquidation process?
Yeah, okay. So the liquidation process is basically this function that you can see here. So you have to define which DNFT you want to liquidate, and you have to define a DNFT that gets your reward. Here we check your collateralization ratio. If it's under the minimum, it's liquidatable. If not, then obviously it's not. You have to put in all the DYAD that was minted through that DNFT, which is burned here. And this calculation calculates the reward that you get as a liquidator. Looking at math and contracts, as someone who does this podcast format also, I think is a bit hard. So I have this Excel spreadsheet here, which just collateralization ratio of 1.4 gives you 77%, 1.3 gives you this, and so on and so forth. And this controlled by the liquidation reward of 0.2 that we have here, which is fixed. So these are the exact numbers that you're going to get as a reward. After calculating these rewards, we loop over every vault you have in your position and move over the reward that you get as a liquidator. So you actually, there are no ERC20 transfers involved when you're liquidating, but only internal moves So when we look at it at the move, it just increases and decreases a mapping that maps from your DNFT to the amount that you have. I hope that answers your question, my fry.
Yeah, good explanation. Thank you. I would just love to hear your personal opinion on why you guys use the soulmate. My fry says yes, thanks a lot. Why you use the soulmate owned instead of Open Zeppelin ownable? Is it a lot gas cheaper, or is there another reason? Do you just like its implementation more?
Okay, so my approach is use the soulmate implementation if it exists. If it doesn't exist, I use Open Zeppelin.
Yeah, nice. Okay, like with Safe Cast, I saw that was Open Zeppelin because there's no equivalent yet.
Yes, exactly.
Okay, nice. I also really like Soulmate.
Yeah, me too. Yeah, it's minimalistic. It does the job.
It's efficient, and you're on mainnet, so efficiency matters a lot.
Yes, we are. Yeah, definitely.
Yeah, cool. I noticed none of your events were indexed. Is there a reason for that, or is it just you don't need index events and topics in your architecture for your front end and back end? Or did I miss some?
Good question. So there.
Oh, they are indexed. Sorry, it's just always in the interface, so I didn't see them.
Yeah.
Interesting that you don't define the function skeleton. You just define the events and errors.
Yeah, good question.
Is it because everything's so general? Because a vault can be many a thing.
Okay, so about comments. Okay, about NetSpec. I think if you're writing a big NetSpec, you can make your function simpler. It's an indication that maybe your function is too complex. We have a version of the contracts with the NetSpec in it. I chose to present this one because I thought maybe on stream it's easier.
It is easy on stream, yeah.
And the functions aren't that big, so you don't need to go through the NetSpec in order to understand the function. But obviously, if you have like a 50 lines function that does a lot of calculation stuff, the NetSpec is super helpful. Yeah.
Yeah, that makes a lot of sense.
Yeah, but I also, when I write NetSpecs, I put them in the interface. I don't put them.
Me too. I like that, and then you just inherit doc. Yeah,
exactly.
It's clean.
Exactly. Maybe also I'm a big, I like to talk about code style. So why do I do? Let me find an example. Like this, like putting everything under each other. Like
I'm such a fan of it.
Yeah, me too. And this is an artifact of my machine learning data science background. Yeah.
I see.
Yeah.
That makes sense. Yeah, I learned this in a protocol called Coffee that I was working on with a developer called Sam Goodenough. And now I always try line things up nicely. It's easier to read, but we use a linter at Alchemia, so it always moves it back, and then when I make the PR, I move it back and moves it back. But I like it. It makes it so clear to read what you've done here, the blocking.
Okay. Yeah, I like that. I was fortunate enough that I was only the only developer of these contracts.
Oh, a dream.
But actually, if I had someone else, I would never use a linter for contracts. I don't know. Some things the linter cannot pick up, like very subtle things.
Like what you've done here with the
for example,
for your constants.
So you know what is annoying me here is actually why I didn't do this. Why didn't?
I see.
Exquisite, yeah.
It's
things
fine,
you notice when you stream your code.
Yeah, but I'm actually gonna push this after the stream. Okay.
Nice. Wow, I'm really impressed. I think it's a great system. And it makes a lot of sense what you said, how it started quite convoluted and complex, but now by this version, it's simpler. I think protocols do tend to become simpler and more elegant over time. But this is one of the most elegant and simple architectures I've seen that's still so effective. Yeah, it's really cool. Thanks for showing it today.
Yeah, thank you. I appreciate that. And talking about complexity, I think you have, when you're trying to raise money, you have the incentive to make it more complex than it needs to be. It's the truth. It's unfortunate, but it really is. So we are very lucky that we have very, very smart angel investors that care deeply about keeping things simple and doing step by step. But yeah, I can understand sometimes there's no other way around it, and you have to put in the complexity. But we were fortunate enough that we didn't. Obviously, it's a bit frustrating when you have to rewrite the contracts like 6 times, as we did. But when you see the end result, I think it's worth it.
It's so worth it. I strongly agree with that. Yeah. So it's cool that your staked ETH uses Lido. I really like what's it called? Acid to tokens or something. But like that you just call those elegant. But with the Chainlink Oracle, I've heard somewhere that they return 0 when the price isn't valid. So they don't say invalid data. They just always return a value, and it's 0 sometimes. Have you noticed that ever happening? And in your math, would that prevent any issues? Because I see there's no check for it. You also have the stale data, though, to also check that it's active data, which is really good. It's good to see that. Answer, yeah. I see. So you get the answer from...
Okay, so that it returns 0 is new to me. That would be bad.
Yeah, I must double check that. I'll DM you if it's true, but I think I've seen that in another protocol that used the Chainlink. They had 0s, and then they had to check if it's 0, trying to use the old data instead, because...
Okay. Well, yeah, definitely DM me if that's the case.
Cool, I will.
The thing is about I'm pretty confident about the asset price function, because it's like the oldest one in the contracts. Like in the six versions that we wrote, I don't think this one has changed. So a lot of eyes looked at it, but yeah, if it returns 0, that wouldn't be good.
Yeah, let me check. Let me do that now. I might be wrong. I hope I'm wrong.
Yeah, let's hope so.
Sorry for the stress if I'm wrong.
No, it's actually, that's a good point. Like this is the, we are at I don't know, what's the TVL we have right now. Let me see. Which, when you see the TVL number go up, it's it does something to you as a smart contract developer. Okay, we're not at 1 million yet, but this is still a big number, for
that's super impressive.
Yeah,
huge.
So yeah, let's hope you're wrong, Tamara. Okay.
I hope so. Sorry.
So I can sleep good in the future. Okay.
Yeah. Sorry. I'll let you know right now. And then, so you and I both believe in solo auditors. Who are some that you would recommend?
Okay, so we had Zach Obrant, Violet, and Philogy.
Oh, nice! Wow,
yeah,
epic. And 3 is a good number.
All are really good.
Yeah, absolutely. Good recommendations. Thank you.
Yeah, really, really good guys. Very, very smart.
Yeah, really, really awesome. So Price says, are they not expensive? They are rock stars.
Well, DM me if you want to know that. I don't think I can make that public. But it's an order of magnitude cheaper than the bigger auditing companies in the space.
And really good quality, I find, when you go with a solo auditor, because they really work hard. And I think it falls through the cracks of a team sometimes. There's always miscommunication in a team.
That's true.
Right. Does the audience have any other questions?
Let's give some time for anyone to type anything up, but I think we're good.
Awesome.
That was a great.
Maybe. Thank you. Well, thanks for having me. Maybe one last thing. We're planning to build a lot of things on top of that. So we're looking for smart people for write Solidity, but also for the front end. So if you're a good tech guy,
Calling all developers.
Yeah, definitely reach out to me.
Cool. You know where to go. Cool. Thank you so much, guys. Any last comments? Anything else to add? No. Cool.
Just thank you. This has been epic. It's a really cool.
So
cool
good.
project.
Thank you.
Yeah, thanks for having me, guys. This was a lot of fun. This was
Cool. I hope you don't lose sleep, but it was really good.
I might be wrong. I really hope I'm wrong. I'll let you know. I'm figuring it down.
Cool. Thanks, guys. I'm gonna end the stream, but it was cool. See you.
Bye, guys.
Cheers.